All right, everyone, welcome back to my YouTube channel. Today we're going to be going over simplifying rational expressions. So just as the learning goals for this lesson are going to include, you should be able to, by the end of this lesson, be able to simplify rational expressions to their most simple terms, state any of the restrictions for all the possible variables, as well as factor rational expressions and state the restrictions as needed. So, if you remember when we were talking about rational versus irrational numbers earlier on this week, we were talking about how a rational number is a number that can be put into a fraction format. So here we can have something where a and b are integers, and it would be a over b, where b cannot equal 0. And that's because you cannot have a denominator of 0. So rational expressions are basically anything that involves a division of polynomials. So for example, you can have 2 over x. You can have x squared minus 4x plus 4 divided by x squared minus 4. You can have x over 2x plus 3 or x over 6. All of these involve polynomials, something with variables of some sort. So because rational expressions are going to carry a variable term in them, they are going to have certain restrictions that are put on them. And these restrictions basically are restrictions put on the denominator because you can't have division by 0. So that means that any restrictions that need to exist on these polynomials are such that the denominator cannot equal 0. So if we go back to those ones that I had suggested before with what we define as a polynomial expression, let's think about what restrictions must be placed on the variable of each of the following equations. So if we have 2 over x, right, we say that the entire denominator cannot equal 0, so that just means x in this situation cannot equal 0, right? Because if x was equal to 0, we would have something like 2 divided by x, and that would mean that overall our formula would be equal to an undefined variable because you cannot do division by x. Okay, so then moving on, I would suggest try pausing the video here and trying these on your own. Okay, and if you've done so already, let's go ahead and take these up. So if we have here, our entire denominator cannot equal to 0 here. So we're going to look for some number that if we did x plus 3, it would give us 0, and that's what x cannot equal. Another way we can do this is we can say, okay, x plus 3 cannot equal 0, right? And like treat the equal sign as an inequality, solve the same way. So it becomes x cannot equal -3, right? Which makes sense. If we were to plug -3 into that equation, right, -3 plus 3 is equal to 0, and then we would have an undefined variable. Okay, let's do the same thing on this side. Try doing these on your own, but I will go through them if you need me to. If you understand the concept, you can simply skip over this or try them on your own and then go look up the answers after. Okay, so here we have x cannot equal 0, right? And then we're going to take this bracket because it's just like that product sum rule. So 2x plus 1 cannot equal 0, right? So either this bracket nor this bracket can't equal 0, and then this bracket also cannot equal 0, right? Because if any of those brackets equal 0, we know that two brackets, if one of them is 0, we're going to get a 0 product, okay? So then let's just isolate, take that 1 over to the other side, becomes -1 divided by 2 divided by 2. We have x cannot equal -1 over 2. So the restriction here is going to be x cannot equal 0 and x cannot equal -1 over 2. Moving forward, here again, we're looking at what can our denominator not equal to 0. So x minus 3y cannot equal 0. Now, this gets a little bit tricky because you have an x variable and a y variable. When you're stating the restrictions, you need to make sure you state them for all variables possible. So let's start with the x. Let's isolate for x. That's fairly easy. X cannot equal 3y. right? And now we want to also isolate for the y variable, so x minus 3y cannot equal 0. I'd still take the 3y to either side because it's easier to work with non-negative numbers. And then just isolate for y, so to get rid of, you gotta get rid of the 3. So we know x over 3 cannot equal y. So again, we have two restrictions here. We have x cannot equal 3y, and then we have x cannot equal y over 3. Or sorry, x over 3. Okay, so now if we go on and we're going to talk about how to simplify rational expressions, it's fairly easy. So the first thing you're going to have to do in this situation is going to be you're going to have to factor. Okay, and this is why I'm saying that whole factoring thing is so important, is because you have to come back to it. So step one now is going to be to factor both the numerator and the denominator completely. Then you're going to also find any restrictions. You're going to find that by taking any factors of the bottom denominator, making sure that we have all of those in a case that it cannot equal 0. Then we're going to divide out and simplify. And then last but not least, we're going to include the restrictions in the final statement. Always make sure you have a final statement. So we'll start with E because it's fairly easy. So let's do the first things first. Let's factor fully, right? So if you remember, that's step one, factor fully. Now I'm writing these steps in for you to see. Obviously, you do not have to do that. Okay, so if I look at these two, 15x squared and 6xy, I know that I can take 3x out of the top one and it'll become 5x, right? And I can take 3x out of the bottom one. The reason I took out the 3x is because I needed to cross something out, and I knew from the top one, if I'd taken out the 5x, I can't take out 5x from the bottom one. If I'd taken 6x, I can't take it out from the top. So I wanted to find the lowest common multiple between 15x squared and 6xy, and in this case, it was 3x. Now, before I do anything, I'm going to go ahead and state my restrictions. I know you're tempted to cross things out, but don't do that first. Always state your restrictions. So now we know that we can't have 3x equal 0, and we have 2y cannot equal 0. So if we isolate, cannot equal 0, isolate again, y cannot equal 0. So those are two restrictions. Then we're simply going to go back and divide out and simplify. And cross this 3x out. I'm left with 5x over 2y, right? And I'm always just going to say, okay, therefore 5x 2 over y, where such that x cannot equal 0 and y cannot equal 0. And the reason that it's so crucial to state your restrictions here in this step and not in the last step is because here it's obvious that y cannot equal 0. But even if you cut out and split up these, or sorry, you cross out the x's, it's still a restriction. So you need to make sure you state your restrictions before you start crossing anything out, because the reality of the situation is that when you put stuff back into the equation, that x is still a restriction. It still needs to be such that x cannot equal 0. Okay, and it's not as obvious in the final answer here because you don't see the x in the denominator once you simplified everything out. Okay, so that's why you need to state the restrictions like that. So try doing f on your own as well as g, and then the ones that I've pointed out to do on a separate piece of paper. So I'll go through F and G with you. The answers for the other ones are posted. I might just go over just one example with you. So I'll go over A with you, but the rest of them are posted. So I would like for you to try those ones on your own and then just review the answers. Okay? All right. So if we go here, first things first, let's go ahead and figure out what we have to factor. You can't really factor the x more. It's as factored as it can get, right? But we can factor out 3x from this bottom denominator right here. So let's go ahead and pull out 3x, right? So I'm going to do 3x squared divided by 3x and 15x divided by 3x, right? And what's left for me in the bracket is going to be x minus 5, okay? And then I'm just going to go ahead and state those two restrictions. So 3x cannot equal 0 means that x cannot equal 0, right? X minus 5 cannot equal 0 means that x cannot equal positive 5. So those are my two restrictions here now, okay? After I'm done stating my restrictions, I'm just going to go back up here and cross things out. So I can cross this x out. I'm still left with a 3 at the bottom. I can't cross this x out because it's an addition and subtraction, so that's not factored out. You can only cross out the things that you factored out. So then I'm left with 1 over 3x minus 5, such that x cannot equal 0, x cannot equal 5. Or you could write this as 1 over 3x minus 15. I just distributed 3 in. X cannot equal 0. X cannot equal 5. So that was just I distributed back in. Okay. So now I'm just going to go over number A with you. Or sorry, we'll do G as well. G is a little bit tricky. So let's do this one. I actually really like this question. So let's go ahead and factor it out. 2 minus 3x, just by looking at it, I really can't take anything out. So I'm going to leave it as is. Okay, so I'm going to leave it as 2 minus 3x. For 6x minus 4, I know I can take out 2. So I'm left with 3x minus 2. Now, if I look at these two, the top and the bottom, I notice that they have the same numbers and the same variables, the signs are different. So what can do basically is I can either factor out a -1 from the top to make it the same, or I can factor out a negative from the 3x minus 2 to make it the same. It's really up to you. So in the solutions I posted online, I factored it out from the bottom, right? In this video, I'll factor it out from the top. You'll see that you'll get the same answer, so it doesn't really matter which way you do it. So let's take out a -1 from the top. So I'm just pulling out a -1, which means that everything on the inside I'm dividing by negative. So it becomes -2 plus 3x. Because you always want to write it with the positive first, it becomes 3x minus 2. And you'll notice now there's a 3x minus 2 in the bottom as well. Right, now that I've factored fully, let's go ahead and pull out those restrictions. So the restriction is going to be 3x minus 2 cannot equal 0. Okay, so 3x cannot equal 2 over 3 over 3. So we know that x cannot equal 2 over 3, right? And then if we want to go ahead and now make the statement, right, we can cancel this out. So we have -1 over 2, such that x cannot equal 2 over 3. And again, this is why it's so important to have done your restrictions before you started canceling stuff out, because you see how this doesn't have any polynomials in the denominator. It still has a restriction because the original has a restriction. Okay. All right, let's do A together on a separate piece of paper. So I'm just going to scroll down and I'm going to write out A again. So it's equal x squared minus 5x minus 6 divided by x squared minus 36, right? So first things first, you're always going to factor the numerator. So let's go ahead and factor a numerator, right? So I'm just going to go ahead and factor out this portion right here. We have x squared minus 5x minus 6, right? We're going to find two numbers that when we add them together will give us -5. When we multiply them together will give us c, which is -6. And we know that those numbers are going to be negative 6 and positive 1, right? So then our m and n, we're just going to put them in like that. So we now factored out the numerator, right? Let's go ahead and factor out the denominator. So I'm going to do that in pink. Okay. So the denominator is a difference of squares. We have x squared minus 36, right? Take the square root of the first term, square root of the last term. We have x minus 6, x plus 6. Now I'm going to go ahead and write that back down as my regular, sorry, as a fraction again, but now it's going to be x minus 6, x plus 1 divided by x minus 6, x plus 1. I just took the numerators and denominators and put them back where they were. Right, go ahead, let's state the restrictions for this. So x minus 6 cannot equal 0. It's just equal to x cannot equal positive 6. X plus 6 cannot equal 0. X cannot equal negative 6. So those are my two restrictions right here. Now I'm just going to go ahead and cancel out anything that needs to be canceled out. So the negative 6 and the negative 6 can be canceled out here. So I'm left with x plus 1 over x plus 6, such that x cannot equal 6, and it's plus minus 6. So I'm just being a little bit lazy, but you can write as two separate things. And that is the answer. Okay, so try, and I would say really actually try, pause the video here and try to do B and C on your own. And then the solutions are posted online, so feel free to go through and do those ones on your own, and try them out. I'll go ahead and I will do B and C here, together, and then, or actually I'll do B. C is a little bit more tricky, so, and it's just because it is a longer process. So go ahead and look at that in the solutions. And if you have questions, you can ask tomorrow in class. So let's do this one together. I'm going to use the X method to do this one with you. Actually, no, I'll do this by decomposition. So we have 10x squared plus 25 minus 15. So I always like to start by factoring off the top, right? And I like to start by going, it's just easier that way for me. So I go numerator, denominator, and then because my denominator is done, I just do the restrictions right away. Then I go ahead and then I put them back where they need to be and cross things out. So let's do the numerator. This is a complex trinomial, which means that it has different rules than a simple trinomial, right? And if you're not sure about that, we have a video on that as well. So please go back and look at it. So here the m plus n are going to give me 25, the middle term. When we multiply them together, it's going to be 10 times negative 15, which is 150. If you look at these numbers, you can actually see that before I do any of this stuff, and these numbers are huge, I can actually just factor. I can factor to 5 from here because all my numbers are divisible by 5. So I'm left with 5, 2x squared plus 5x minus 3. And now these numbers are so much easier to work with. So now if we had to go find m and n, we would have 5, right? And then m times n is going to equal 2 times negative 3, which is just equal to negative 6, right? So now in this situation, we know that our numbers are going to be 6 and negative 1 again, right? And instead of putting them as m and n, we have to just do decomposition. So we'll be left with 2x squared plus 6x minus x minus 3, right? I just broke down this middle term into these two from these numbers over here. Okay, so then I'm left with 5, 2x, and let's go ahead and factor out actually now that we're here. So what can I factor out with these two if I had a bracket around them, right? I can pull out 2x. My leftover is going to be x plus 3, right? If I go here to this portion right here, I can take out a negative 1. I'm left with x plus 3. right? And now I'm left with 5, 2x minus 1, x plus 3, right? So I'm factored my numerator. I'm going to move on to my denominator. So my denominator is 2x squared plus 12x plus 18, right? Right off the bat, I know I can pull out the 2 from here. I have x squared plus 6x plus 9. I look at this and I see that this is a square rootable number. This is a square rootable number. 3 times x is equal to, times 2 is equal to 6x. So I know that this is what we call a perfect square trinomial. And I know that the shortcut is for a perfect square trinomial. You take the square root of the first term, which is x, square root of the last term, which is 9, the sign in the middle, which is, square root of the last term is 3. Square root of the last term, which is 3, and then the sign in the middle, which is a positive, and just square it. And remember that you still have the 2 outside. So that's my new factored. I'm just going to break this down into x plus 3, x plus 3. And I think you'll understand why shortly. Just trust the process. But this bracket, x plus 3 cannot equal 0, right? So x cannot equal negative 3, which is because they're same brackets, it's the same restriction on both. Okay, so now let's go ahead, put that back where it needs to be. So I'm left with 5, 2x minus 1, x plus 3 over 2 x plus 3, x plus 3. This is why I put it like this. It's very easy to see that these two x plus 3's cancel each other out. So I'm left with 5, 2x minus 1 divided by 2, x plus 3, such that x cannot equal negative 3, because that's my restriction, and that is my answer. Okay? All right, so now your job is to attempt to do this one, and make sure that you're careful because this is going to be two of them are both complex trinomials, right? So make sure that you're using the complex trinomial. You can use the X method if you would like, or decomposition. I'm just going to show you decomposition. I do agree that the X method can be faster for a lot of people, so do it whichever way makes sense for you. And then make sure you state your restrictions before you start dividing things out. And yep, so that's really it. Have a great day.